The focus of this video lesson is stock market regression equations. Example 1. Examine the 36 consecutive trading day closing prices of ZZB. The chart covers the trading days from January 6th to February 26th. Construct a scatter plot and find a regression line and the correlation coefficient. Use the equation to predict the closing price on the 37th trading day of ZZB. So the first thing we do here is we type all of the data into our spreadsheet. Each trading day, starting at that January 26th date, all the way through our February date, will each be assigned a number. So the first date will be trading day 1, the second date will be trading day 2, and so on. Then we will have all of our closing prices that correspond with each of the 36 trading days. Now, what we would like to do is create a regression equation of this closing price data over this 36-day time period. So we're going to start by highlighting both the trading day column and our closing prices column. We're going to go to Insert, Charts. We're going to choose our scatter plot option. We're going to have it label both of our axes. And our horizontal axis is going to be our trading days. And our vertical axis is going to be our closing price. And we'll label this ZZB stock. Now, what we want to do is create a linear regression equation. So if you remember from earlier this year, we find any point on the graph and we right-click on top of that point. We go down to the option that says Add Trend Line. We'll see that our line of best fit or trend line will appear, and this menu appears over on the right. We're going to ask it to be linear, and we're going to have it display the equation on the chart. You'll see that the equation appears here. I can change the color so that it stands out more. Now, because this equation is representing a change in money, I'm going to make sure that my equation has the place value of money. So when I click on the equation itself, over here in my menu, I'm going to click on the one that looks like a bar chart, and I'm going to change it from category general to currency or money. Now, I'm also going to have it display my R-squared value on the chart. Now, in reading this equation, I can say that the ZZB stock is increasing at a value of about 11 cents per day, because remember, X here is our horizontal axis or trading days, and that the initial or starting price on, say, day 0, right, or the day before our first day, was at about $33.58. Now, there was a couple of things that we were asked here in this problem. The first of which was to construct a scatter plot, which we've done, and refine a regression line, which we've done, and we have not quite done this one, find the correlation coefficient. So let's jump back to Excel and let's look at how we do that. Now, this R-squared value is actually the square of our correlation coefficient. Now, if you remember from earlier this year, our correlation coefficient simply tells us how closely our linear model here actually fits the data. If the scattered points fit perfectly on the line, the correlation coefficient will be a 1. If the line does not nicely fit, if the points are scattered far away from the line, then our correlation coefficient is closer to 0. So think of 1 as being 100%, right? It's perfect. And think of 0 as being 0% or not good, right? Not a close fit. Now, in order to get our correlation coefficient, we are going to type in the formula equals Correl Shift 9 to get our open parentheses, and what it's going to ask for is the two variables that we're trying to find correlation for. So I'm trying to see if there's a correlation between trading days, so I'm going to select my trading days data, comma, is there a correlation between my closing data? So you'll notice that it actually highlights the two columns of data that we're looking at here. And we get that our correlation coefficient is that 0.93882. So we'll label that correlation coefficient. Now, like I said before, this r-squared value that we get from our chart here is actually going to be the square of this correlation coefficient. Now, let me show you what I mean. So the 0.88 is the square of this number. So if I were to square root our 0.88, you'll notice that we get approximately the same number. So if you would like, you can actually get this correlation coefficient simply by square rooting this r-squared value, or in this case, the square root of 0.88. Now, the next part of our problem was use the equation to predict the closing price on the 37th trading day. So right now on the 26th, we are at 37.13. Now that we have a model or an equation to determine potential closing values, we're gonna try to figure out what the 37th trading day could potentially be based off of this model. All right, so if you take a look here, you'll see that our equation is y equals 11 cents x plus 33.58. All right, so we have y equals 0.11 x plus 33.58. And what we want to know is what will happen on the 37th day. So when x is 37. So we're simply going to substitute in 37 for x. So we have y is equal to 0.11 times 37 plus 33.58. Then using our calculator, 0.11 times 37 plus 33.58 gives us $37.65. So we could then say on the 37th trading day, we expect the closing price to be about $37.65. Now do note that this won't be perfect, right? That this model is supposed to allow us to make a prediction that is reasonable based on the trends we've seen so far with this particular stock. And then speaking of trends, we could argue that the ZZB Corporation is seeing a current upward trend, right? There's positive growth. The stock is increasing at about 11 cents per day, and it seems to be following that path, at least for the last 36 days. And that's pretty much it for example 1. Now it's your turn to give it a try. What closing price might be predicted for the 38th trading day? Please show your calculation and submit it. Example 2. Use the data from example 1. As we have seen previously, sometimes you can get a better regression function by using polynomials. Determine the quadratic, cubic, and quartic regression equations, and then make a prediction for each of the closing prices on the 37th day using each of those models. All right, so what we're going to do is we're going to just pick up off of where we left off with our linear. Once again, we're going to highlight our two columns, but this time when we create our scatter plot and we attempt to create our model, we are going to right-click once again and add a trend line, but this time we're going to ask that it be polynomial. We're going to start with order 2. And order 2 is going to give us what's called a quadratic polynomial. And we're going to ask it to display the equation just like before. Now we know this is quadratic because it actually has that highest degree 2. So the highest power we see or exponent we see is that 2 right there. So we have our quadratic regression model. And we'll highlight that in red as well. Now you'll notice that the data, because of this curved shape, fits almost a little bit nicer than the other one. Now, if we actually display our R² value, you'll actually notice that this number is actually even closer to 1 than our linear model because the data fits closer to the path of where the closing prices are actually moving. All right, now we're going to repeat this, but this time, when we create our scatter plot and add our trend line, we are going to choose polynomial, and this time it's going to be an order 3. Now, mathematically speaking, an order 3 is what we refer to as a cubic regression. And once again, we will have this display on the actual chart and the R² value. And you'll notice that this one is an even better fit because our R² value is now a 0.93. And remember, the closer that number gets to 1, the better the model will be at predicting. Okay, now let's do just one more. So once again, I'm going to highlight, add my scatter plot. I'm going to shrink that down just so we can make it fit. And once again, right click, add trend line, polynomial, this time order 4. And you'll notice that this one has our R² value the closest to 1, meaning this is actually the best fit so far. Now you'll notice that some of these values are really quite small, and so you'll see that when the equation displays, it displays in this exponential notation, so we might have to play around with the place value so that it displays the numbers. All right, so like I said before, we have our linear regression for ZZB, our quadratic with the 2nd degree, our cubic with a 3rd degree, and our quartic with a 4th degree. And we'll notice that our R² values get closer and closer to that 100%, right? So remember, the closer it gets, the better the fit. Now, what they want us to do is to use each of these equations and then determine the approximate closing price. All right, so once again, they want us to determine the 37th day. So literally all we're gonna do is take each of these equations and simply replace the x with 37. Paying close attention to exponents. And then simply using a calculator to calculate. And we'll literally do that exact same process for all of these. And we'll do that for the cubic and the quartic as well.